Okay, so in this video, we're going to be talking about completing the square. There are instructions on how to do them, but I think it's easier just to see through an example. So what I'm going to do is show it on the first part, and then show you a little bit more complicated one in the second video. So what we're going to do here is we're going to first look to see if there's a leading coefficient or a number which is attached to the largest exponent. And there is none here except for 1. So we can go ahead and just start completing the square process. So what we're going to do is we're going to take the number which is attached to the y, and we're going to divide it by 2, and then square it. Now, in order to do this, what you're going to do is you're going to add and subtract the exact same number. Okay. Now, the reason why you do this is because this part right here is actually equal to 0. So if you add 0 to something, you don't do anything to the actual column. And what I mean by that is x plus 3 plus 0 is just x plus 3. So even if I added 0 to this, it does nothing to the actual expression itself. So this right here does nothing to this. It doesn't change it. But it is useful because now what we can do is complete the square. So I'm going to go ahead and write the completed square version of it, and we'll see that the actual distribution later on will give you back the original. So the first 3 terms these first 3 parts are the completed square part. So what it looks like is always going to be the variable, the sign, and the number inside of the square. All squared. And then the constant comes down. So the constant is going to be 9 over 4. And this is given by 3 over 2 times 3 over 2. And multiply straight across. So let's take this, and we're going to show that we get the inside part. So y plus 3 over 2 times y plus 3 over 2. The first one, second one. So the first is given by y squared. The second one is given by plus 3 over 2y. Then we get the next term, which is again plus 3 over 2y. And then 3 over 2 times 3 over 2 we did up on the top, which is going to be 9 over 4. These two can be added together already because they have like terms. So this is going to be y squared plus 6 over 4, y plus 9 over 4. Sorry, this is 6 over 2. Okay. And then 6 over 2 is 3. So this right here, this y squared is that y squared. This 6 over 2y is 3y. And then lastly, the 9 over 4 is given by 3 over 2 squared. So we get back the original equation when we do this actual distribution part. Now, it's called completing the square because this thing right here is not a square. So what I did was I was able to rewrite this as a square. That's why it's called completing it, because I added something to make it a square. Now, let's go ahead and do this problem over here. This problem is a little bit harder because of this 3 in the front. So before you can actually start completing the square, you need to factor out the leading coefficient. So 3 times w squared plus 4 over 3w. Now, you may have learned this a little bit differently, but you actually only need to factor out the leading coefficient from the variables. You don't need to do it from the constant. So I can just leave the constant alone. Now, once you have that property, you do the exact same thing here, which is take the number attached to the variable without a square, divided by 2 and square it. So this divided by 2 is given by 4 over 3 divided by 2, or 4 over 3 times 2, which is 4 over 6. Okay. Now, you can simplify things if you want to. The real part that you don't want to simplify is the square. So what I mean by that is we can write this as 2 over 3. But remember, this part over here, this square, we want to leave alone. Okay? And the reason is because if you evaluate this square, this does not come straight down anymore. So you just want to leave it like that without actually simplifying it any further. If I add it, I need to take it away so that I'm adding only 0. And then the plus 6 is still on the outside. So the first 3, those are always given by the variable, the sign, and that number, 2 over 3. Don't forget to break that number down. So what we have used so far is everything to the left of that negative 2 over 3 squared. So what you need now is to distribute this. Because notice the 3 got multiplied to the first 3 terms because these first 3 are that orange part. But we need to distribute this 3 to the last part, which we haven't done yet. So this is going to be minus 3 times 2 over 3 squared. And now simplify everything. This is 3 times w plus 2 over 3 all squared. This is really 2 over 3 times 2 over 3 times negative 3. So those cancel. And you're left with minus 4 over 3 plus 6. And then I'll just do this on the side. 4 over 3 plus 6 is 4 over 3 plus 18 over 3. So I multiply top and bottom by 3, which gives you multiplication of 1. And this is going to be 22 over 3. So this 4 over 3, minus negative 4 over 3. So 18 minus 4 is 14. So this is plus 14 over 3. This is the completed square form of the polynomial on the top of the quadratic.